Hey guys, welcome back to another episode of the Real Hacker Hours podcast. This is basically where I just do the normal work I would in side projects. I just hit the record button before I do it. Today, we're going to continue looking at postfix reversing, particularly with I have effectively scripted out here just a script that will effectively just handle a data transfer, not data transfer, a mail transfer to a email account that postfix actually has locally will actually store the email. And I can show that to you here. So the mailbox itself is for a local user guy in a tuxedo. You see right now it has nothing in it. Run the script. We see here is the data for the email transmission, the email being email time. And then we run it. Okay, we see that it now has an email stored in the mailbox. So that's proof that the script is actually having postfix hit the code paths to receive and store email. I'm going to quickly go through the various commands here. We see there's 1, 2, 3, 4, 5 commands. The hello command effectively just starts like it starts like an SMTP session. Mail from this command is what initializes effectively a mail transfer from the client to the server. Just indicates, hey, I'm sending a mail and this is the address that I'm sending it from. The recipient, this command here specifies who the mail belongs to. For my current understanding, you can have like multiple recipient commands to specify multiple targets for the email. And also you might know that like the domain I'm working from right here is all localhost. And then next data, this actually specifies, oh hey, this is the data that I want the email to actually contain. Which is right here. The terminator is just also backing up one thing. If we look at the actual hex dump of the protocol, we see here that all the messages are terminated with a 2-byte sequence OX0D, OX0A, which kind of say that on a lot of different protocols that are like SMTP, the clear text. And to terminate the data section, you just need that terminator followed by a dot followed by another one of those terminators. That's why you see here email time, but let me pull this back up. Yeah, that's why you just see the email times, you don't see the dot. And then quit, which just exits the session. But yeah, I kind of want to take a look now that in the previous episode, we've identified, oh hey, we know the locations of where the code that actually handles these commands are. I want to take a look and see how exactly that works under the hood. So, cool. Let's first see. So this is the process 4549. I'm going to go ahead and connect to it in GDB. Wait a second. Oh, wait, no, it's not actually running. Okay, no. From what we saw last time, the SMTBD process only starts up when you've initialized a data. Oh, in fact, yeah, initialized a connection to the SMTBD server. Telnet 127.0.0.1. I'm seeing right here. Okay, so you just have to connect to it. So, and if we kill this, is it still up? I wonder if I can attach to it now. 4588. Cool. Just make sure this is the right one. This is a function which, due to previous work, I know exists. So I'm going to go ahead and assume that this process that I'm currently debugging is the one that is going to actually handle the SMTP traffic. So the first thing I want to verify is, based upon my current understanding, since I'll be sending a hello command followed by a mail, followed by recipient, followed by data, followed by quit. I want to verify that the functions that I've identified that I believe handle those are going to get called in that order. So I'm going to set a breakpoint for hello cmd, hello mail command, hello recipient command, hello data command, and hello, no, hello, break quit command. So you set 5 different breakpoints for the 5 different functions we should be seeing here. Now I'm going to go ahead and run this script after continuing GDB to see if it does follow that order. Continue, Python 3. Okay, cool. So we've hit a breakpoint at hello command, mail, recipient, data, quit. And then, okay, cool. So the commands did get executed in the order they're expected to, and let's just verify that. Okay, and it will continue to handle the rest of the commands. Cool. So, or the subsequent request that we send it. Okay. Now let's start taking, now that we've definitely verified that those functions are though, or we have a good reason to believe that those functions that we've set breakpoints for are the ones that handle it, let's start taking a look at it in the source code. What is this, master.c? Okay, this is probably where it happens. Okay, process a hello command. Let's take a look. Hello command argc. I get the feeling that what argc is when you look at SMTP traffic, yeah, you see that the commands take arguments, and judging from the fact that typically argc and argv deal with arguments, I get the feeling that they are the arguments to the command. However, we're in a debugger, so we can looking at the hello command function, we see that argc is stored in the second register, which looking at the registers, RDI, it's RSI, which is 2, which makes sense because it counts the command itself as an argument and one additional argument, which is what we sent it. But looking through here, if argc is less than 2, it sends out effectively a reply saying, hey, this isn't syntactical. Yeah, this syntax isn't correct because it should be hello hostname. And if it is more than 2, then it sends out another error. So it only expects 2 arguments, one of which being the hello command. Cool. I'm not sure what that is. Push command will log rejected string with correct. None. Another error check of some sort. And then we see hello reset, chat reset, mail reset, recipient reset, all of which is state. So looking here, there's an SMTPD state struct, which seems to hold the current state. Now, one thing, what do I mean by state? Looking at the traffic, we see that there are several commands here that rely on previous commands, such as an order mail from establishes, hey, we're sending mail to this is from who. Recipient to and data rely on the beginning of a mail transfer. So without like recipient, without a previous mail command, when you send it recipient, it doesn't know where the mail's from, so it'll just return an error. If you're specifying data, it has a reliance on the state which is established by the previous commands. Basically, what the state is in this instance is let me think for a second how to explain this. Yeah, the state is effectively like what is going on with the SMTP server. Is it sending a mail? Cool. Who from? Where from? Because previous commands rely on the state to actually tell what's going on. And hello. Downgrading the protocol name breaks the unauthorized. Okay, so I think the meat. Wait, what is this? Looks like this is some sort of like protocol downgrading. Downgrading the protocol. I'm not quite sure what that is, but I think the meat of what we need to look at is this hello reset and all of these different resets. So I'm going to save that here. Does this happen in, well, is the function declaration for this in this file? Yes, it is. Cool. Takes in the state. If state hello name, if this is set, then it frees the state name, so it's probably mallet. State name, hello name, if Milter. Don't know what Milter, maybe a ongoing mail transmission of some sort. If RV free. So it looks like it's effectively just freeing memory in the hello reset. Let's look at chat reset. I don't know what functionality the chat reset has. Chat reset. Notify postmaster. If state history. So it looks like if there is history, I'm not sure. Maybe like history of sending a mail in this current session. Looking at these comments, notify the postmaster. Seems like this just reports errors if there are any. Let's look at mail reset now. Reset mail. Okay, this looks like it has a good bit of functionality to it. Okay, cool. If mail state cleanup does not equal 0, runs basically, if it needs to, runs up some sort of mail stream cleanup. Not sure what that is. Probably just flushes the data stream, something like that. Freeze the state QID if it does not equal to 0. Freeze state sender. Okay, it's looking like in the state there's a lot of different effectively things that are mallet, and it looks like it's just effectively freeing all of them here except for if it's a yeah, these are proxy. Yeah, it's looking like it's just effectively freeing stuff. Oh wait. And let's take a look at recipient reset. Okay, it's also just freeing stuff. So let's go back to the hello command. Okay, and remember the hello command effectively, I believe it just freed the hello name. I'll look at it one more time. Yeah, it freed the hello name. This EHLO, that's like stands for extended hello. Since we're dealing with hello, I'm not right now too worried about that. Yeah, hello reset effectively just freed a single variable, and which is the state hello name. When you see right after this is done, it effectively just sets that name. So effectively, what looks like the hello command function does, in addition to a lot of error checking, effectively just frees a bunch of stuff relevant to the current session and just sets the hello name of the current state. Cool. Next up, so we have a good idea of what that does under the hood. Next up is mail from, or the mail command. So let's look at that. Process the mail command. If our hello required, and it looks like, oh hey, this is a check right here to see if it requires, well, basically if hello was sent beforehand. Check to see, oh hey, are we already in a mail command state? Apparently, okay, I'm not sure what the BDAT command is right now, but it looks like you can't also run enter into like a mail state when you're already in a BDAT state. So it looks like it's requiring a minimum of 3 arguments, so the mail followed by 2 arguments does not appear to be an upper limit to that. More error checking here. It's checking here the actual like tokens that of the arguments it was passed. For inarg equals 3. Inarg. Not sure what it's doing there. Body. Okay, so it's looking like in the mail command there's some additional things you can specify like size, body. Message size exceeds. Reject site. Okay. Looks like it's checking for a potential like size overflow there. Right, equals environment ID equals. So this is effectively, it looks like there's additional parameters that can be passed through the mail command. It looks like it's just scanning them in there. Show the envelope center and reject logging. Looks like here it's actually trying to like verify the address that you're sending it to. And yeah, it looks like here is where it will actually begin where it will like begin the mail transfer functionality. Now, one thing I believe SMTBD will work. Now, Postfix itself will have, well, can have, probably will have a number of users specified as like local, meaning like, oh hey, I am responsible for like storing mail or like handling mail for like these set users in this domain. If it gets a request for mail that is outside of it, I'll try forwarding out. If not, it will just store it here. An example that is specified with this, it's for a local account. That's the reason why I was able to like actually show the mail on my local system and then just forward it off. Looks like a lot of the functionality here, especially down towards here, is just trying to verify like, oh hey, is this like a local account? If not, send it elsewhere. So we have a good idea of that. I might come back to mail later, but for now I want to look at recipient command. RCPT. Wait, no, I'm doing this wrong. Command. Okay, cool. Checks if it's proceeding on mail command. Checks to make sure it's not after a BDAT command. Check if there's a minimum number of arguments. Check for maximum amount of recipients. Okay, so as I stated beforehand with my previous reversing efforts, SMTPD will attempt to tokenize the strings, which is where it takes in like an ASCII string like this and converts it to like, oh hey, mail from, we're gonna use like an integer value to specify that this is a mail from command. And here it's just checking the tokens that it was used to, well, that was generated from attempting to tokenize that string. Notify. Okay, it looks like there was some additional arguments or things that can be specified with the recipient to command. Checking for there. Another check to see if there's like too many recipients. Has a function which checks if to see if it's a valid sender address. Okay, it performs a check on the sender address there. Don't access the proxy. Proxy the recipient. Okay, so we lied. Store the recipient. Remember the first one. Okay. Okay, cool. I'll look through that. Now onto the function that data processes the data command. Okay. This if oh, this is just checking. Oh, hey, recipient count 0 because if there's 0 recipients at this stage, you should have specified a recipient. So this is just checks for to make sure that it's in the correct state. It should only have one argument here. This is the check is for here. Since the data command effectively just specifies the contents of the email, the data will be sent later. SMTPD check data. If it's a proxy, okay. Well, yeah, what a proxy effectively proxy is it's middleman between like a sender and receiver. So instead of like directly sending data to a server, you would talk to some intermediary which would talk to the server for you. Appears to be handling it now. Common receive a data message. Okay, this is so it appears to set up the data transfer and the receive data messages where it actually will receive it. Void. Okay, cool. I'm actually kind of curious how it receives data. First, string compare, 4, 6. What is it actually in here scanning the data? Oh, SMTP get. SMTP get. Copy the message content of the cleanup. Does SMTP get only get called once? Let's see. Get mail command, recipient command, data command, SMTP get. Okay, yeah. What we saw there, SMTP get is kind of like the standard. What we're seeing here is that's a standard function for like receiving data from the SMTP get stream, and we saw there it's very clear that it was only called once to scan in the entire data. So cool. And lastly, let's look at quit. Okay, it doesn't have any syntactual checking. It just is it here. That's interesting. And it does not appear to actually free any memory. It will simply just flush the what looks like to be the stream and just exit. Doesn't actually appear to actually change the state, which is kind of interesting. Okay, cool. So looking at here, we can tell that like what these commands here do under the hood of Postfix and the SMTPD binary. This right here effectively like frees there's a part of the what SMTP will do is it'll keep a state like I've said before, which for that being there will be a lot of different data points which will actually have malloc. Hello will effectively just free most of those and just set the hello name. Mail from this will effectively, well, give me a second. Okay, cool. Yeah, I'm back now. But yeah, effectively looking at it, SMTPD will keep a struct which stores a lot of information as to the current state. Looking at these functions or these commands, hello effectively just resets it. Recipient to and mail from will effectively just edit that state to reflect that what the commands are saying, with specifying like where the mail is coming from and to. Um, yeah, data will effectively just scan in the email, and if it's a proxy, it will send it to an outstream. If not, it will store it locally. And then quit doesn't actually affect the state at all; just flushes the stream. But yeah, one important thing that we saw here was there's a ton of checks, such as like, oh hey, too many recipients and that sort of thing. Now, with what Postfix has been around for like 20 years, open source target, fairly commonly used. As such, the code base for this particular project has been fairly hardened down. Now, there are a ton of SMTP servers out there, and there are a lot of bugs in them. So these checks will kind of give us an idea of like different ways that we can like probe for bugs in other targets, such as like, oh hey, having the insane amount of targets. I'm trying to particularly do execute commands when you have not set up the state for it, or the state is not correct to execute those commands and that sort of thing. This has been going on for about 30 minutes, so I'm going to cut off here. Thank you for watching.